Yeah, Hamza, you can try leaving and then joining again. That works mostly. Okay, everyone. So let's begin with this. Quadratics. This is the next one that we're doing now. Uh, let's begin with this. So first of all, there are some things that some concepts that you already should know from O levels. Some very basic stuff like solving quadratic equations. So you can solve quadratic equations using factorization, using that's the middle term breaking thing, right? Or the quadratic formula. Um, Solving equations using completing square, that's not necessary for you to know. But quadratic formula and factorization, you should know both of these methods. So I think you already know how factorization works, and I'm not going to spend time on that. For instance, in this case, 2 into minus 4, that gives you minus 8. So you think about the factors of 8 that, when subtracted, give you 7 somehow. So in this case, that's 8 and minus 1, and that gives it split into two parts. So we break the middle term, and then we factorize whatever we can from the first two terms and from the second two terms, and we get the result from that. Now, at this point, this is something that you must understand. You have two things multiplying. When you have two things multiplying and the result is equal to 0, that means necessarily either the first thing is equal to 0 or the second thing is equal to 0. When you have a product, the result can only be 0 when at least one of those expressions is equal to 0, right? So either the first is 0 or the second is 0. Compared to an equation like this, 2x minus 1 into x plus 4 equals 2. Now, this is not true. This is not correct. If you do it like this, that you say either 2x minus 1 is equal to 2 or x plus 4 is equal to 2, that would be incorrect. That would not make sense. It only makes sense when you have 0 on the right side, because 2 could come from any other combination as well. It's not necessary that if the product is equal to 2, then 2x minus 1 is equal to 2 or x plus 4 is equal to 2. Not necessarily, because we could have 2 when we multiply, for instance, 0.5 and 4. That also gives us 2. It's not necessary that any of them has to be equal to 2. When it's 0 on the other side, then it's necessary. You can't get a product of 0 when at least one of those numbers is equal to 0, right? So that's why we put each expression equal to 0 in those questions separately like this. How do you solve an equation like this? You would have to simplify this, take 2 to the other side, solve it as a normal quadratic, and that would work. All right. Now, when you are factorizing, be careful. Sometimes what happens is when you take wrong factors inside the bracket, you end up getting different signs. Don't forcefully make them the same. Okay, let's just make the second one x plus 2 as well. Don't do that. That basically is a sign that you're doing something wrong. If the expressions inside bracket, they turn out to be different. Okay, so how do you solve this equation then if factorization does not work? You have another method, that's quadratic formula. You take everything to one side, and then if something cannot be factorized, in this case, for instance, you cannot factorize this. It's given in the formula sheet as well, minus b plus minus square root of b square minus 4ac divided by 2a. You know how this works. The first term is a, this is b, this is c. Just input values and you get the result. Now, when you're solving equations when you're solving any quadratic equations, it's necessary to show working for that. You cannot write down answers directly. You will not get marks for that. You will not even get marks for the answer, even if that's right, if you're not showing the method. Okay, so showing the method is important. If you're using the quadratic formula, at least show this particular step where you input the values in the quadratic formula. Then you can write down the answer after that. But if you write down the answer without showing this step, you get 0 marks for that part. Okay, you don't get any marks for that. So make sure that you show at least this step when you are solving using quadratic formula, and at least factorize. Okay, this is important. Okay, so that's how we solve quadratic equations. Now, what exactly do these solutions represent? So we solve this equation, 2x squared plus 7x minus 6 equal to 0. We got two values of x equals 0.712, x equals this. What do these values represent? These values represent the x-intercept. These values represent x-intercept of x-intercepts of this function, right? The values where the graph of this function, the function on the left side that cuts the x-axis. Why is that? Because this graph that I have, this graph is 0. We get this on the right side. Now, when is y 0? When y is 0, we have the x-axis. Right? That's the equation for the x-axis, y equals 0. So when we have an equation like this, when we solve this, the solutions of that equation that represent the x-intercepts of this function that is there on the left side. Okay. Now, you need to know how to sketch graphs of quadratic functions. There are two shapes that you can have. You can either have a U shape or an N shape. The first shape or the second shape, smiley face and sad face, however you want to remember that. How do you get each of these shapes? If the coefficient of x squared is positive, if it's positive, you get the first shape. If the coefficient of x squared is negative, you get this second shape, the N shape. Okay. Now, there are some properties of this graph that you need to know about. It's called parabola. You should know that name. It's symmetric about the center of the curve. So if you draw a line here like this, it's the line of reflection of this curve. So the graph is symmetric about this vertical line. And this point here, this is the turning point of this line. We can call this the minimum point in the first case, and this is the maximum point in the second case. There are multiple names that you have for this point that, again, you should be familiar with. You can call this point turning point, you can call this vertex, and in different names of the same point that you should know about. Now, on one side of this quadratic function, on one side of this quadratic function, the function is going to be decreasing, and on the other side, the function is going to be increasing. For example, in the first case, if it's a U-shaped graph, on the left side, you see, the graph is going in the downward direction. As you go from left to right, the graph is going downwards. So if you think about the gradient of this graph is negative. If the gradient is negative, we call this a decreasing function. And if the gradient is positive, we call this an increasing function, right? Again, we'll do this in differentiation later on as well. Sometimes you get this in quadratics too. On the right side, this is an increasing function, okay? For the other curve, on the left side, the graph is upwards, so gradient is positive. On this side, the curve is increasing. On the right side, when it's going down, the curve is decreasing because the gradient is negative on that side. So you need to know about these properties of these graphs. Also, this constant that you have here, the C, that is the y-intercept of this graph. That's true for all polynomials, for cubic as well. Whatever is the constant value, that's the y-intercept of the graph. How do you find turning point of a quadratic function? If you just need to find the turning point and there's nothing else that you need, you don't need a specific form as such. In that case, what you do is you say, let's use the formula x equals minus b over 2a. This is the formula that you have to find the x coordinate of the turning point of a quadratic function. X equals minus b over 2a. If you say this is a and this is b, you can use this formula minus b over 2a, and that gives you the x coordinate of the turning point of this function. Okay, how do you find the corresponding y coordinate? You put this value of x. For example, in this case, we got this. Put this value of back in the value of x back in the function. That gives the corresponding y coordinate, and that's the turning point of this function. Okay, it comes from the quadratic formula. If you forget this, just think of the quadratic formula. In the quadratic formula, just get rid of this part, and that's minus b over 2a. That's actually where this comes from. That's the x coordinate of the turning point of a quadratic function, right? That's the quickest way of finding this, apart from differentiation. That also works the same way, similar way, as in the same number of steps. That's how you can do that. Now, there's another method that you need to know. That's completing the square. Sometimes they will specifically ask you to complete the square for a function. Now, how will that work? Now, this is the standard method that most of you would probably be familiar with for completing the square. Let me go through this first. So one possibility, square means you want something that looks like this: a into x minus h whole square plus k. Now, different they could use c here in place of k, the completed square form. Now, how do you convert this function to this form? That's the question, right? Now, this is one way to do it. Whatever is the coefficient of x squared, you take that common outside. You have to make that coefficient 1 first of all. You take that common outside. So you take 2 common. And then what you do is the coefficient of x after you've taken 2 common outside, you divide this number by 2. 7 over 2 divided by 2, what does that give you? That gives you 7 over 4. Now you will square that number. You'll square that number, and both add that inside the bracket and also subtract that inside the bracket. Okay, so this is a fraction that makes it a bit more complicated. If it was, for instance, inside was squared inside bracket, and that will give you the perfect square. But a lot of times you get fractions like this as well. You should know how to do that. So yeah, if you have 7 over 2, you divide that by 2, square that, and you add that number here and also subtract that number inside the bracket. And now these first 3 terms, they give you a perfect square. From the first term, you take just x. From the second term, you take the sign. And from the third term, you take this number that is inside. And that gives you this perfect square, x plus 7 over 4 whole squared. And then outside, you've got this left. You simplify this. And then at the end, what you do is you multiply this number 2 inside the bracket. And that gives these identities. Where are they? Do they have them here anywhere? No. So this process basically comes from those identities that a square plus 2ab plus b minus whole square, right? That's where it comes from. That's the logic behind it. But that's what you need to remember. Now, if you want to use this method, that's what you do. You take the coefficient of x squared common outside, and then you divide the coefficient of x by 2, square that, both add and subtract that inside the bracket, and then you get a perfect square from these first 3 terms, and then you simplify everything, and you get that result. Now, this is the standard form that we've got, a into x minus h whole square plus k, right? Now, in this form, h and k are the coordinates of the turning point of the function. So in this case, for instance, if you've got from this form, you would compare with the standard form. In the standard form, you've got minus h. You'll need to remember this. You should remember this one. X minus h whole square plus k. Compare these numbers, this number and this number. Minus h equals 7 over 4. That gives you h equals minus 7 over 4. Compare the numbers outside. That's minus 81/8 and plus k. The value of k turns out to be minus 81/8. If it's the standard form like this, all you have to do is change the sign of this number. Minus 7 over 4, keep this sign the same, that's minus 81/8, and that gives you that turning point. So using this completed square form, what you can do is you can find the turning points as well. However, if you just want to find the turning point and they've not asked you for a specific form, in that case, minus b/2 is much quicker. But if you have already converted something to this form, then you can write down the turning point directly from this form, flip the sign, and this remains the same. These are going to be the coordinates of the turning point if it is the standard form. If it is the standard form, this is one way of completing the square. Another way of completing the square is using this method, which I think is much easier, much quicker when you have more complicated expressions like this. For example, when you have fractions, in these cases, this other method is much quicker. But since a lot of students have learned that first method at O levels, they don't trust me on this for some reason, and they still stick to that. So a lot of people, they find learning new things difficult. But think about this: if you had that same expression, 2x squared plus 7x minus 4, you want to convert this to the standard form, a into x minus h, the completed square form, right? What you can do is you can mix up those two methods that we have learned. Remember what the standard form is. The standard form of a complete square function, it's a into x minus h whole square plus k. A standard completed square form. Now in this form, you know that h and k are the turning points, the coordinates of the turning point. If you remember this form, what you can do is you can find the turning point using b over 2a to find the turning point. It turns out that the x coordinate of the turning coordinate of the turning point, that is minus 7 over 4, and the y coordinate is minus 81 over. No, this is the value for h, this is the value for k. Just input those values here. A is going to be the same as this. So A was 2 here. That remains the same. A is 2. And then you just input the values of h and k there, and you get that completed square form, and that's it. All right, that's another alternative that you have for this form, for converting something to that form that you can also use. Now you can use whatever you prefer. This is another possibility, however. All right. Okay. Now, if you have the completed square form, from that, how do you write down the coordinates of the turning point? We discussed that. You flip the sign in the middle. For the x coordinate, you flip the sign, it becomes minus 3. For the y coordinate, you just keep the sign. That's minus 8. Okay. And you can look at it for the rest of these extensions. Whether the maximum or a minimum is decided by the number outside. If it's negative, then that's a maximum. We know that's going to be an shaped curve, be a minimum, because that shape is going to be a U-shaped curve like this. Now, sometimes you'll end up getting something like this. 2 into x minus 4 whole squared. What about this? What's the turning point of this? There's no number outside. Since there's no number outside, we assume that that's 0. So the x coordinate is 4 and the y coordinate is 0. If you have this 5 into x squared minus 3, what about this? What's the turning point of this function? You can think of it like this. You can say this is 5 into x minus 0 whole squared minus 3. The number inside is 0. So the x coordinate of the turning point, that's going to be 0. And the y coordinate is the number outside, that's negative 3. That's the turning point. Okay. And sometimes you get a slightly different completed square form. That's not the standard form. For example, you'll get something like this. 4x minus 8 whole squared plus 7. Now, what's the turning point of this function? For this function, we are not just going to say that the turning point is 8 and 7. That's not correct, because this is not standard completed square form. We've got this 4 inside as well. In the standard form, we can't have any coefficient of x here. So in this case, the x coordinate is not going to be 7. The x coordinate is going to be found by equating this thing to 0. 4x minus 8 equal to 0. And that gives us x equals 8 over 4, which is 2. The x coordinate is going to be 2 and 7. That's going to be the turning point, 2 and 7. Okay. So the general rule is whatever is inside, you put that equal to 0. That gives you the x coordinate of the turning point. And the number outside, that's going to be the y coordinate. That works in this case as well. For example, for x plus 11, if you put that equal to 0, you get x equals minus 11. So that's the x coordinate, right? If you have 4x minus 8, you put this equal to 0, you get x equals 2. That's the x coordinate, the coordinate of the turning point. For the y coordinate, it remains the same as the number outside. That remains 7. Okay, so that's how you complete the square. Now you've got the concept of discriminant. So for any quadratic function, we have something that we call discriminant, b square minus 4ac. B square minus 4ac. You saying something? Okay. We'll discuss that. That's coming. Okay. X square minus 7x plus 12. Let's say we got a function like this. If we solve this equation, how many roots do you get from this? You get 2 different roots. If you solve, now this equation, you solve 2 equal roots. If you solve another equation, you get no real roots. What's the difference between all of these 3 equations? I got 3 equations here. These are the 3 functions that they are: the blue one, the green one, and the orange one. I solved all of them, and it turned out that one of them gave me 2 different solutions. One of them gave me 2 equal solutions, and the other one, the last one, gave no real solutions. What's different in all of them? Look at this working. In one of them, inside the square root, I'm getting a positive number. In the second, I'm getting 0. When I have a positive number, I get one value with plus that and another value with minus that. So I get 2 different roots in this case. When I have 0 inside the square root, I get 6 plus 0 and 6 minus 0. That does not change anything. Both these points turn out to be the same. When I have negative inside, that does not give us anything because square root of a negative number, that is not real. So we don't get any solution from that. So this number that's inside the square root, that's very important. What's that number? That's basically this discriminant b square minus 4ac. Inside the square root, you've got this thing called b square minus 4ac. We call this discriminant. That is basically what decides how many roots you're going to get for a particular quadratic equation. Now there are three different cases, in fact, four different cases, three base cases, and then one is derived from them. One possibility is, in the first case, for instance, when the number inside is positive, you get two different solutions. So when b square minus 4ac is greater than 0, you get two real and distinct equal solutions. Or you can also say that's just one real root because it's the same thing coming twice. And the last case is that you have no real roots. When does that happen? When b square minus 4ac, the part inside the square root, that's less than 0. In that case, you get no real roots. Now, graphically, what does that mean? Graphically, what that means is the function that we have and the line that we have on the other side. In this case, the line was the x-axis. Sometimes it could be some other line as well. The graphically that the curve, in the second only point line is the curve, and in the third case they're not meeting at all. So you should understand both the graphical interpretations and the interpretation using the roots. When b square minus 4 in the curve, they intersect at two different points. When b square minus 4ac is equal to 0, they often say it like this: the line is a tangent to the curve, or we can say the line only touches the curve or only meets the curve at one point. And then finally, in the last case, b square minus 4 is less than 0. The line and the curve, they do not meet each other, right? So whenever you have any of these statements written in the questions, understand what that's referring to. At 2 points means this is greater than 0. It's tangent to the curve. It's equal to 0. They don't meet. B square minus 4ac is less than 0. Now, this is only for quadratic equations, right? When you get a quadratic equation after equating the functions, it's only for that case. If you're not getting a quadratic equation, then b square minus 4ac is not relevant. Then you use differentiation. That's not what we're discussing right now. But then we have another case. Sometimes what they say is two functions, they have real roots. Or they might say the line and the curve, they meet each other without specifying at how many points. So if they have real roots, they could have, two different roots. They could have two equal roots, one root, two roots. We're not sure about that. If they say the line and the curve, they meet each other, now at how many points do they meet? Do they meet once? Do they meet twice? We're not sure about that. When they say any of these statements, when it's not clear whether it's at 2 points or 1 point, you basically combine the first two cases. You say, in this case, b square minus 4ac is greater than or equal to 0. That's the combination of the first two cases, because it could be any of those two, right? If the line and the curve they meet, that means they could meet at 1 point or 2 points. So we combine these minus 4 is greater from the first two cases. Okay, now let's have a look at this example. So we did completing square above. Sometimes they ask you to convert something to a form that is not the standard completed square form. For example, they might ask you to convert this expression to this form, 2x plus a whole squared plus b. Now, this is not standard form. In this case, you've got 2x inside. In the standard form, you cannot have any number inside the bracket multiplying with x. In this case, they have that. Now, how do we deal with problems like these? One way to do this is that you complete the square the normal way, whichever way you prefer. You can do it that way, right? I've done this using minus b over 2a method here. You can do it using the other method. Eventually, what happens is you get this standard form, right? This is something that everyone can do, I think. You get to this form. But now they don't want, in the form that they've given, they don't want any number outside the bracket. They have a number inside the bracket. Now, what do we do for that? The number that's outside 4, we take that inside. But we can't take that inside as it is, because this bracket has power 2 and this 4 only has power 1. They have different powers. In order to multiply 4 inside, we need to make the power the same for the number outside as well. How would that work? we write 4 as 2 squared. And now, since the powers are the same, that means you can multiply the base. So it becomes 2x minus 3 whole squared minus 9. And that is the form that they wanted there. This is one way to do this, that you do it using the standard way. And then the number that's outside, you write that in square form and then multiply the base inside. And that gives you the result. Another possibility is using comparison method. This is also something that can be used for normal completing square as well. It'll work there as well. So what they did was they gave us this expression and they wanted us to convert it to this form. We can compare them. We can say, okay, this is the original 2. We can say, let's simplify this thing. 2x plus a whole square plus b. What does that give us? That gives us 4x squared plus 4ax plus a squared plus b. And now we could compare the two. We can say the coefficient of x squared is 4 here. This is also 4. That does not give us anything interesting. The coefficient of x here is minus 12. This is 4a. You compare them, the value of a turns out to be minus 3. And the constants, there's no constant here. This is a squared plus b. We compare them. And that gives us a squared plus b equal to 0. So we get two equations. 4a equals minus 12. That gives us the value for a. A squared plus b equals 0. And from that, we can find the value for b. And then once we have those values, the value for a and value of b, all we have to do is input those values in that form that they gave, and that gives us the final form. All right, so that's what we can do as well. Okay, let's move on now. I think around 15-20 more minutes, probably. Let's see, because there is still some stuff to go, because we have some difficult questions coming up that might take a bit of time. Okay, now let's look at another example. Let's say we've got a curve that looks like this: y equals x squared minus 3x plus 4. We need to show that the whole of the curve lies above the x-axis. How do we do problems like these? The whole of this function lies above the x-axis. Now, what's the shape of this graph? It's a U-shaped graph. The coefficient of x squared is positive. Since it's a U-shaped graph, what I'll do is I'll just get rid of that part. Yeah, okay. If it's a U-shaped graph, that means it looks like this. Right? Now, if the whole of this curve has to lie above the x-axis, then that means the turning point here, its y coordinate should be positive. So how do we prove this? We find the turning point of this function. What's the turning point of the function going to be? This is the function y equals x squared minus 3x plus 4. Find the turning point, minus b over 1.75. And the y coordinate turns out to be 1.75. Since that's positive, that means it's above the x-axis. It's a minimum point. The minimum point is above the x-axis. If the minimum point is above the x-axis, that means the whole curve, therefore, is going to be above the x-axis. Right? That's one way to prove this. Another way to prove this could be, if the whole curve lies above the x-axis, then you could also say that the discriminant is going to be less than 0, right? So you find b squared minus 4ac for this. That turns out to be negative, but that's not enough proof. That's not sufficient proof. If you just say b squared minus 4ac is less than 0, it could be two possibilities. It could either be this form, or it could be this, that the whole curve lies above the x-axis if it's a U-shaped curve, or it lies below the x-axis if it's an N-shaped curve. B squared minus 4ac less than 0 could mean either of these. So if you use b squared minus 4ac method, in that case, you would say b squared minus 4ac is less than 0, but at the same time, it is a U-shaped curve. So it's this case, not this case. And these things, both of these things together, they mean that the whole curve lies above the x-axis. That's another method that you can use for this as well. All right. So either the minimum point lies above the x-axis, or find the discriminant that's negative, and also say that it's a U-shaped curve. That is why the whole curve lies above the x-axis. That's what you had to prove there. Second part, that's also another important one. Find the set of values of x for which this is a decreasing function of x. Now, we talked about increasing and decreasing function before. It's a U-shaped curve. If it's a U-shaped curve, we know this part here is decreasing. The part that has a negative gradient, that part is decreasing. Now, what's that part? What are the values of x in this part? We found the turning point. If you did it using the turning point method in the first part, you can just use that. If not, you would have to find the turning point in this part now. The turning point was 1.5 and 1.75. They wanted us to find the set of values of x for which this is a decreasing function. So decreasing function is on the left side of the turning point. What are the corresponding values of x that we get from this? To the left of 1.5, that's x less than 1.5. That's the solution that you have there. Okay. All right. If you have to find point of intersection between a line and the curve, you just solve them simultaneously, right? Just like coordinate geometry. This is a line. This is a curve. If you make subject in the linear or another equation, you can solve it simultaneously like this. Okay. All right. Now let's look at this. We have a line that has this equation mx minus 2m. Okay, so I'm going to skip the first part. That's pretty straightforward. Let's say we have a line mx minus 2m. And they're saying, find the two values of m for which the line is a tangent to the curve this. The line is a tangent of the curve. Does that remind you of something we just discussed? If a line is a tangent of the curve, that means b square minus 4ac is supposed to be equal to 0. Right? If line is a tangent of the curve, b square minus 4ac is supposed to be equal to 0. So now we have a straight which is mx minus 2m, we have a clue this curve. So that means they are only going to have one point where they meet each other. So b square minus 4ac should be equal to 0. Now, how do we use b square minus 4ac? The first thing we have to do for using b square minus 4ac is we first of all equate these two functions. We start the process of solving them simultaneously. Either do substitution or make the same variable the subject and equate both of them. Once you equate them, you get one single equation like this, right? Using those two equations, when you start solving simultaneously, you get one equation from that. You convert this equation to the standard form ax squared plus bx plus c equal to 0. You bring all terms to one side and leave only 0 on the other side. Okay, once you've done that, the coefficient of x squared, that's going to be 1. That's going to be the value for a. The coefficient of x, that's going to be the value for b. So if you have multiple x terms or multiple x square terms, you take x and you see what the coefficient of x turns out to be. In this case, that's minus into 4 plus m. That whole thing is the coefficient of x. So that's the value for b. And then similarly, the constant is everything that does not have any x in it. So that's the constant. All right. Now, this is the constant, 5 plus 2m. Since the line was a tangent of the curve, we put b square minus 4 is equal to 0. Solve that and find the values of m that we get from that. Now, sometimes what they ask you for is to find those points at which the line is a tangent of the curve. Once you have found the values of m, now you know what that equation is. You know the equation of the line now. Where it will be two possible cases, right? One possible case when the value for m is 2. In that case, you have y equals 2x minus 4. The other possible case is when m is equal to minus 2. In that case, you get this equation. And now what you do is you solve these two equations simultaneously to get those points at which the line meets the curve. Okay? All right, let's move on. Hidden disguised quadratic equations. Sometimes you have equations that are in this form, such that they're not quadratic. However, you can convert them to a quadratic form. For example, you could have something like this. X raised to the power 4 minus 7x squared plus 12 equal to 0. This is not a quadratic equation. This is a power 4 equation. Now, we don't have a general method that we have in our syllabus to solve quartic equations, power 4 equations. So how do we solve this equation then? We can think of it as a quadratic equation. It's a hidden quadratic. How do we do that? And how do you figure out if it can be converted to this form? The powers should be in the ratio 2:1. The power should be in the ratio 2:1. One power should be twice the other power. So in this case, one power is 4, the other power is 2. One is twice the other. What we do is we use a substitution. We replace the smaller power with another letter. So in this case, we say that u equals x squared. And then u squared will become x raised to the power 4. Solve this equation, put that substitution back at the end. In place of u, you put x squared back again, and you get the solutions from that. Compare that with this equation. In this case, substitution does not work because the powers that you've got, there are three different powers, right? You've got x power 4, x power 2, x power 1. So substitution does not work here. That would not work. It's not a hidden quadratic equation. If you had something like this, 6x into 7x raised to power 1 over 2 plus 2, again, in this case, that works because you've got one power and the other power is twice that. So it does satisfy that condition. We replace the smaller power with another letter and then solve it as a quadratic. And then at the end, we put that substitution back. This is another example. You have these two equations, and we have to find the points of intersection of these two curves. This is one curve, this is another curve. How do you find points of intersection? If you were to equate them, you would get an equation like this: x raised to power 2 over 3 minus 1, that equals x raised to power 1 over 3 plus 1. And that gives you x raised to power 2 over 3 minus x raised to power 1 over 3 minus 2 equal to 0. Now, one power is twice the other. You can see that this is 1 over 3, this is 2 over 3. So what you do is you replace the smaller power with another letter. You say u is equal to x power 1 over 3, and then u square would be x raised to power 2 over 3. And this can be written as a quadratic equation: u square minus u minus 2 equal to 0. You solve this quadratic equation, at the end, put that substitution back, and you get the result. Next thing you have to know about is solving quadratic inequalities. How do you solve quadratic inequalities? When you solve the equation, what do you get from that? For example, if you solve this quadratic equation, x square minus 7x plus 12 equal to 0. When you solve this equation, you get two answers from this: x equals 3 and x equals 4. They represent the x-intercepts of this function, right? Why? Because we've got this function y, and we're saying that is equal to 0. When is y equal to 0? Y is equal to 0 on the x-axis, right? So these solutions represent the x-intercepts of this function. But what if instead of an equation, we have an inequality? For example, if you have something like this less than 0. Now you cannot do it like this, that you say, let's just factorize this and then say either x minus 3 is less than 0 or x minus 4 is less than 0. That's not how it works, because if both numbers are negative, their product is actually going to be positive, right? So it's not going to be negative, it's going to be positive. So this logic does not work when you have an inequality. So how do you solve inequalities then? Whatever inequality it is that you have to solve, what you do is, first of all, you treat this as an equation. Treat this as an and find its x-intercepts. So remove the inequality sign, treat this as an equation. You know how to solve the equation. You can solve it like this. Find the values of x that you get from that. Now it's a U-shaped curve. Draw that U-shaped curve and think about it. If it's a less than sign, that means y is supposed to be less than 0. You're supposed to be below the x-axis. Which part of this graph is below the x-axis? That's this yellow part. What are the corresponding values of x for this part? 3 to 4, right? It's between 3 and 4. This part of the graph is below the x-axis when x is from 3 to 4. So that's what your answer is going to be. You say x is between 3 and 4 like this. When you write this form, when you have middle region, you always write it like this: smaller number on the left side, bigger number on the right side, and you have less than signs, these signs in the middle. Okay, whenever you have two-way inequality bounded on both sides, you always write it like this: smaller on the left, bigger on the right, and less than signs in the middle, right? That's the convention that we have for writing down this inequality. Now, if instead of less than sign, you had a greater than sign there, what would you do in this case? When is y greater than 0? That's this part or this part, right? This is where the y value is greater than 0. So what are the corresponding values of x that we get from this? Either to the left of 3 or to the right of 4, right? These are the corresponding values of x that we have. So that means x is either less than 3 or it's greater than 4. Since in this question statement, you had an equal to sign as well, we put equal to signs with the solution as well. All right. Okay. So these are the inequalities that we get. This is the solution to this equation. Now, if this inequality was like this, if the coefficient of x square was negative, then you would say it's an n-shaped curve, right? So you would draw an n-shaped curve. So if it's a less than sign, what does that mean? Where is the graph below the x-axis? It's to the left of -1 over 2 and to the right of 4. So you solve it as an equation, first of all. Once you solve the equation, you find the values of x from that. And then using the graph, you can write down the final inequalities. Another possible way of doing this could be that if you're not comfortable with a negative sign here, you can just multiply the whole inequality by minus first of all. That will change the inequality sign as well. That will make it positive, because whenever we multiply or divide by a negative number, the inequality sign also changes. So now we've got this inequality. Treat this as an equation, solve this equation, you get two x-intercepts again, but now in this case, since we have a greater than sign, that means we're looking for the for the part of the graph that is above the x-axis. The corresponding values of x that we get from that is to the right of 4 or to the left of -1/2. Right? These are the corresponding values of x that we get from this. So that's the solution. Now, just an exam trick that I sure you would like. If you have this inequality, and you don't like graphs and you often get this wrong, you can just use your calculator. How do you do that? You show this process. Where you solve it as an equation, right? Treat the inequality as an equation. Find the two x-intercepts. Once you find the two x-intercepts, this is what most people get wrong. The final solution that just really helps. So on this version, I have this inequality solving function. I can just go there. The degree of this polynomial is 2. Let's put that there. That's number 2 in this. Input those coefficients, -2, 7, and 4. And you get that answer. So after you're done with this part, you found these x-intercepts. If you're not sure about the inequality signs, you get them from the calculator. X is less than -1/2 and x is greater than 4, and that's your final answer. All right. So that's it. That gives you the result. So you don't have to show this graph. There are no marks for showing this graph. You just write down the answer directly. Okay. All right. Okay, let's move on. Now that's pretty much all in terms of concept. Now let's have a look at some tricky questions, and then we end. The equation x squared plus px plus q. Equation x squared plus px plus q equals 0, where p and q are constants. It has roots -3 and 5. We need to find the values of p and q. How do you find values of p and q in this case? This is the equation. We have to find the values of p and q. We are given two solutions of this equation. One solution is -3 and one solution is -3 and the other solution is 5. One idea could be that we say these are solutions to this equation, and you get two simultaneous equations from that. You solve those two simultaneous equations and that gives you the result. That's one possibility. That's one idea. That will work, but it takes quite long. Okay. But a quicker way of doing this could be, it's only 2 marks, right? You're given the solutions -3 and 5. Think about what happens when you solve a quadratic equation. If you have this x squared minus 7x plus 12 equal to 0, when you solve it, you get a form like this first, factorized form, and then you say either x minus 4 is equal to 0 or x minus 3 is equal to 0, and then you get the solution x equals 4 and x equals 3. If you had the solutions given and you wanted to go back to the original equation, how would you do that? You can just go backwards in this direction. You can say, okay, you've got x equals 4, you've got x equals 3. Let's go one step back. Bring 4 to the left side, bring 3 to the left side, and that gives you this x minus 4 equals 0, x minus 3 equals 0. Go one step further back, combine these factors, multiply them, and then you can simplify everything to get back to that original equation. So that's another idea that we could use here that will be much more efficient in problems like these. So you are given that the solutions are -3 and 5. Okay. Now, if those are the solutions, we can say, okay, x equals -3 and x equals 5. That gives us x plus 3 equal to 0, x minus 5 equal to 0. And now we can multiply these two factors, x plus 3 into x minus 5, that equals 0. Simplify this and you get the equation x squared minus 2x minus 15. They told us that the equation is x squared plus px plus q equal to 0. Compare the two, you get the value of p, that's -2, and you've got the value of q, that is -15. That's another way to do this. That's much simpler. Now, there's a complication here that you could have. For example, in this case, if they had said that the original function is of this form, it's not x squared plus px plus q, it's actually -3x squared plus px plus q equal to 0. And the solutions are the same. What happens in that case? How do you find the values of p and q in that case? Now, when you get to this point, you are getting x squared minus, not compare these two equations because coefficients of x squared, they are different from each other. You cannot do comparison in this case. That would not work. In the previous case, they were both the same, so we could compare them. Now we can't. So how do we compare them? We can only do this if we first from this form get to this form. How do we do that? We just multiply the whole equation by -3. Multiply the whole equation by -3 so that the coefficient of also become 5 here. So whatever you know in those equations, those numbers should be equal. So in this case, we knew the coefficient of x squared. So they had to be equal before we could compare these two equations, right? So that's a more complicated example that you would see. All right. Now, sometimes what they do is they don't tell you that the line and the curve, they meet at multiple points. They won't tell you that the line is a tangent to the curve, or they don't meet each other. But they would ask you to show something. So for example, in this case, look at this question. It's a very common one in recent papers now, and it's a bit complicated sometimes. You've got the equation of a curve that looks like this. And you've got the equation of a line that's this. They want us to show that for all values of m, that means no matter what the value of m is, the line intersects the curve at two distinct points. Now, how do we show that? The line intersects the curve at two distinct points. What does that mean? B square minus 4ac is greater than 0. But is that given to us? That's not given. They're not telling us that the line intersects the curve at two distinct points. They want us to show that. So we're not going to start with this assumption that b square minus 4ac is greater than 0. We have to show this. So how will this work? We've got the equation of the curve. We've got the equation of the line. First of all, we equate both of them. Simplify everything. Convert it to the standard form and b square minus 4ac. Now, we are not going to say that b square minus 4ac is greater than 0. We're not going to say that. We're just going to simplify b square minus 4ac. So we input the values of b, a, and c, simplify b square minus 4ac, and that gives us this eventually. 4m squared minus 32m plus 68. Okay, this is what we get. Now, once we've got this form, b square minus 4 is equal to 0, we have to prove that this is greater than 0. This is always greater than 0. No matter what value of m you put there, this is always greater than 0. How do you do that? This is an expression. This is a quadratic expression. It's a quadratic expression. Can you find the minimum point of this expression? Not the minimum point of the original function. Discriminant is a quadratic function here. How do you find minimum point of any quadratic expression? You can do that using minus b over 2a. Right? So from that, the x coordinate of the turning point, that is going to be 4. Put that back in this function, and that gives the corresponding y coordinate. What that means is this curve, see, we are graphing the discriminant. That looks like this. The minimum value of the discriminant, what's that? The value of the discriminant is 4. That necessarily means it's always greater than 0. If it's always greater than 0, that means that the line and the curve, they meet, they intersect at two distinct points, no matter what the value of m is going to be. Does that make sense? This is one idea. The other idea here after this point could be that you complete the square. Complete the square. When you complete the square for this, you would get a form like this: 4 into m plus 4 whole squared. 4 into m minus 4 whole squared plus 4. When you complete the square for this, you get something like this. And then from this also you can say, and this part is always positive, or you can say this is always greater than or equal to 0, right? Because we have 4, that's positive. This is a square. Square can never be negative. And this is plus 4. So that means the overall thing is always going to be greater than 0. Since it's always greater than 0, that means the line and the curve, they intersect at two different points. Okay, that's another idea. You complete the square and argue based on that. What you need to remember is don't put greater than 0 in the beginning. Start with just b square minus 4ac, simplify that, and then the expression that you get to somehow prove that that is always positive in this case. All right. Another similar question like that, you can do that yourself. You've got this curve, you've got this line. Again, they're saying show that for all values of k, the curve and the line meet. What does that mean? Curve, given us how many points they meet at. It could be 1 point, it could be 2 points. Greater than or equal to 0, greater than or equal to 0. It could be both possibilities. But is that given to us? No, it's not given to us. We have to show this. How do we show that? We equate both of them, find b square minus 4ac, simplify that, and at the end, the result that we get, we find the minimum value of that. If it's 0 above, that means b square minus 4ac is greater than or equal to 0. Okay? And then finally, we have this function f of x that's defined for all real values of x. F of x is equal to x squared minus 6x plus c, where c is a constant. It's given that f of x is greater than 2 for all values of x. What does that mean? F of x is greater than 2. It's greater than 2 for all values of x. Okay? Find the set of possible values of c. Now, how do we understand that? So we've got this quadratic curve. It's a U-shaped curve. It looks like this. It's a U-shaped curve, right? It'll have some minimum point. Can we find that minimum point somehow? X squared minus 6x plus c minus b over 2, that gives us x equal to 3. That's the x coordinate of the minimum point. Then we find the corresponding y coordinate. That turns out to be c minus 9. So we've got the turning point's coordinates. The x coordinate is 3, the y coordinate is 7, is c minus 9. Now, what's the range of this function? The minimum point is c minus 9. So the range of the function is going to be greater than c minus 9. Y is supposed to be greater than c minus 9. That's the range of this function, right? They have given us that y is greater than 2. We are getting y greater than c minus 9. Compare the two. What do you get from that? If y is greater than 2, then from here, we get c minus 9. That should be greater than 2. So think about it like this, in fact. If they're saying f of x is greater than 2, then the y coordinate here should be 2, because that's what the y value is greater than. It's always greater than 2, right? So we say c minus 9, that should be greater than 2, and c is greater than 11 from that. Does that make sense? This is one idea. This is one way to do this. This is going to make it much more complicated. Let's just stick to this. So y greater than 2, that was what was given to us in the question. That for all values of x, y is greater than 2. This function is greater than 2. We are getting that the turning point of this function, its y coordinate is c minus 9. So c minus 9, therefore, has to be always greater than 2. So we say c minus 9 is greater than 2. That gives us c greater than 11. All right? So that's another type of question that you will see in recent papers sometimes. That's it. I hope that was helpful. If you have any questions, you can let me know now. And you can finally go and sleep if you want. Although, even though you're saying you're tired and all, you are all going to be watching reels now, watching YouTube shorts. It's only while studying maths that you get tired. Ask her. Sorry, that was not a valid question. Yes, let me know if there are any questions. Can we have two curves instead of a curve and a line? It's possible. You could have curve like this: y equals 2x squared plus 7x minus 4x squared minus 3. The idea remains the same, just equate both of them. If after equating them, you get a quadratic equation, then yes, that's possible, right? Because after equating them, b square minus 4ac only works when after you equate both the functions, you get a quadratic equation. So you could have any two functions. If after equating them, you get a quadratic equation, then yes, that is possible. You can get that. This last question, it's the same idea that we did before. You will equate both of them: 2x squared minus 3x plus 1 equal to kx plus k squared. Take all terms to one side, convert it to ax squared plus bx plus c form. Once you've done that, find the value of b squared minus 4ac. Simplify that. The result that you get, you have to show that that's greater than or equal to 0. Complete the square for that, and that will help you understand that. The one above. Okay, what about this? Do you have a specific question on this? So let me repeat what I've done. So we had to show that b square minus 4ac is greater than 0. We had to show that, right? So what we did was we equated both the functions first of all and found b square minus 4ac. I think you understand until this point at least, right? We found the value of b square minus 4ac and we got this form. And now we need to show that this b square minus 4ac is always greater than 0. No matter what the value of m is, it's always greater than 0. Now, one idea that I explained was that we say it's a quadratic expression: 4m squared minus 332m plus 68. That's a quadratic expression, m squared. You find the minimum value of this using minus b over 2a. Minus b over 2a, that gives you h equal to 4. That means the x coordinate, that turns out to be 4. The corresponding y coordinate that you get when you input x equals 4, here you get the corresponding y coordinate. So this value is the minimum value of this expression, 4, right? So b square minus 4ac, its minimum value is 4. If its minimum value is 4, that means b square minus 4ac is always greater than 0. And that's what you had to prove, that b square minus 4ac is greater than 0. Okay. Yeah, so whatever value of m you have there, since you have proved that the minimum value is 4, it's always going to be greater than that. If the minimum is 4, it can't go below 4. So that's greater than 0. Okay, if you find this confusing, just complete the square. Complete the square and you'll get something like this. 4 into m minus 4 whole squared plus 4. That is what you would get from this. Now, rather than thinking of the minimum point of that curve, because some people may find it confusing that why we're drawing the discriminant there, just think of this expression. This is 4. 4 is a positive number. This is m minus 4 whole squared. That's a square. A square can never be negative. It has to be greater than or equal to 0. It cannot be negative. And then you have a plus 4 here. That's also a positive number. So overall, the whole expression is going to be greater than 0, right? Because we have plus 4, even if this becomes 0, 0 plus 4, that becomes greater than 0. So all you have to write down is, you say b square minus 4ac is, after this, after converting it to completed square form, you can just write b square minus 4ac is greater than 0. And that shows that the line in the curve, they meet for all values of x.